Okay. All right. So every week, someone in your organization uses an AI tool and gets results. They don't know how it got there. Nobody checked. It went into a report, a decision, or an email. That is not an AI problem. It is a workflow problem. The good news, the fix is simple. 3 words: plan, act, verify. Plan means you define the task before the AI touches it. What are you asking for? What counts as a good answer? What are the boundaries? If you cannot answer those questions before you open the tool, you're not ready to use it. Act means you run the workflow with a human in the loop at the right points. Not watching every token, not rubber stamping at the end, in the loop, where the decisions actually happen. Verify means you check the output against the original intent, not does it look right, against the standard. Did it do what you asked? Can you trace how it got there? Would you stake your name on it? Plan, act, verify is not a technical framework. It is an accountability architecture. It works in a spreadsheet. It works in an enterprise system. It works in a 2-person team, and it works in a government agency. Think about the last AI decision your organization made, not the strategy session, not the ethics workshop, the actual deployment decision, the one made under time pressure by the team that needed to ship. Did they ask, what is this system designed to do? Did they ask who answers when it acts? Did they ask who bears the cost of it if it fails? Most didn't. We're living through a fundamental shift. The old model, human prompt, machine answers, human action, a tool. You pick it up, you put it down. The new model, the agent receives a goal, makes a plan, executes actions, iterates. The human is not in the loop. The human is on the loop, watching, approving at checkpoints. If those checkpoints are even there, productivity research suggests gains of 10 to 30% for knowledge workers in agentic environments. Survey data suggest that only 11% of organizations maintain validated oversight over these autonomous agents. We are adding capability faster than we are adding wisdom. AI is no longer a tool we use. It is an architecture we inhabit. That architecture was designed by someone. At each decision point, a choice was made, usually quickly, usually without the right questions. This talk is about those questions. I give a disclaimer now. My views are entirely my own, drawn from my own 30 years of professional experience and my studies in enterprise architecture, security, and technology leadership. They do not represent my employer, any government agency, or any government. Every agentic AI deployment is a choice between 2 vectors. I call them the heaven vector and the Skynet vector. The heaven vector is the accountable, explainable, the human overseen. The systems engineered to extend human capability equitably, intent examined, constraints in the code, not in a policy document. A named human who answers when the system acts. The Skynet vector is unconstrained optimization, intent unexamined, accountability dissolved entirely into the machine. Look at this slide image. One path goes gold, one path goes red.
I think your slides
sorry, the
are
wrong
not
image.
moving
Here we go.
Andreas, your slides,
Yep.
now it's fine. Now it's fine.
Yeah. No one sets out to build the Skynet vector. They set out to ship the product. They set out to meet the deadline. Each individual looks reasonable. The aggregate is not. The word default is doing real work here. A default is what you get when you do not choose, and most organizations, most of the time, are not choosing. Hold on. Sorry for that. So the conference invited me to talk about building a simple agentic workflow, plan, act, verify. I will get there. But before plan, you need 4 specification questions. They're not philosophical. They belong at the top of every design document. First is intent. I think I'm on the wrong slide still. Let me have a look. Here we go. Now I've got it. The first is intent. What is the system designed to do? Have you examined that? Most teams document what the system does. Very few examine why it exists in the form it takes, and whether that form reflects examined values or inherited assumptions. Unexamined intent is the first step towards the Skynet vector. The second is constraint. What is the system designed not to do? More important, is that constraint in the code or on paper? A governance document sitting in a SharePoint folder is not a constraint. A policy that no trained model has ever encountered is not a constraint. Paper policy fails at the speed of business. Third, accountability. When the agent acts and something goes wrong, who is named? The human being who answers, not the team, not the organization. A specific person with a specific mandate whose name you can state right now. If you cannot name that person, you have diffused accountability into the organization. Diffused accountability is no accountability at all. Fourth, consequence. When the system makes a wrong decision, who bears that cost? Almost always it is the affected person, not the deploying entity. The patient, not the insurer. The job applicant, not the recruiter. The benefit recipient, not the department. 4 questions. They take 15 minutes to answer rigorously at the start of a project. Most teams skip them entirely. Let me give you the stakes in human terms. An insurance company built an AI system to assess medical necessity claims. The decision architecture was designed for efficiency, accepting the algorithm's findings, 1 click, frictionless. Challenging it, paper appeals, waiting periods, legal language designed to exhaust the claimant. The result, documented in Gene Locken's case, which I write about in my book and also in my show my viewers on my YouTube channel, an algorithm error rate on reversal of 90%. Actual appeal rate, so patients that actually appeal this 90% failure rate, 0.2%. 90% wrong when challenged. Almost no one challenged. I didn't come up with these figures. They're all part of a court case against the largest health insurer in the United States. Not because the system was malicious, because the architecture made acceptance easy and challenge hard. That is what I call the banality of algorithms. The most dangerous systems do not cause harm through malice. They cause harm through architecture that makes their decisions look final and their oversight look optional. That is the Skynet vector in a health insurance database. No drama, no villain, just design. 4 domains. I'm moving quickly through each one. 1 insight per domain. The pattern is what matters. Domain 1. Imagine an enterprise. A Wellington finance team received an email, technically authentic, corrected format, domain, correspondence style, all matching generic correspondence. It was a synthetic deepfake. A wire transfer of $1.8 million followed, as documented in my book, Lethal by Design. Traditional cyber failed here because it checked technical form. It did not check intent. My model, I called it the AIEA model, adds what I call this cultural security envelope. So a behavioral mismatch detection, the audit of intent, pattern recognition at the cultural level. So would that email look culturally like a New Zealand context email? Would it have, for example, what we have here with our native language, a Maori data or Maori component in it? Also, have we deployed it so that the data is kept holy, what we call taonga? The data is holy. The data, how we believe in New Zealand, is a reflection of our culture, of our entity, of our identity. It's like our image. And that is a security architecture question. Cultural and Maori-based behavioral norms encode legitimate interaction patterns that purely technical filters cannot see. But you can look at that and you can go, well, clearly this email was fraud, was a deep fake. And an AI system would have a hard time to reconstruct that. Hold on, next one. The AIEA model replaces the static architecture snapshot with dynamic agent-aware governance. Legacy frameworks like TOGAF and ZECMAN were built for predictable human-driven processes. They're dangerous when applied to systems that plan, act, and iterate autonomously. The model that I developed adds agent personas with clear decision authorities and security envelopes, and hard escalation triggers, cryptographic provenance chains for trustworthy data, real-time interaction mapping, and ethical guardrails embedded into code and not relegated to a paper policy. Domain number 2, the commons. The enclosure cycle has run 3 times in the digital era. Unix, 15 years from open to corporate control. Cloud, 5 years. AI, 26 months from ChatGPT in November 22 to DeepSeek R1 in January 2025. Each cycle follows the same structure: open, adopt, and close, resist. When open source AI is redefined to mean downloadable model weights under restrictive corporate licenses, the terminology has been captured. Watch the AI governance debates in every jurisdiction asked, whose interests does each proposed definition protect? Domain number 3, military AI, the accountability collapse. 60 seconds on the hardest domain. Published investigative reporting documents, algorithmic targeting system in which an algorithm identified approximately 37,000 targets. The human review step at that authorization stage was documented at roughly 20 seconds per target. 20 seconds preserves the form of human control. It removes the substance. The machine identifies. The human rubber stamps. The accountability gap in military AI governance is not a future concern. The accountability chain that international humanitarian law requires, a named human making a genuine judgment, has been compressed to the point where it cannot carry the moral and legal weight assigned to it. The structural lesson for enterprise AI is direct. Any system designed so that accepting its input is frictionless and challenging is as difficult as reproducing this pattern at whatever scale you operate. Domain 4, orbital AI. In orbit, hyperscalers are currently launching AI compute infrastructure into low Earth orbit. The Kármán line at roughly 100 kilometers marks the edge of generally accepted terrestrial jurisdiction. Above it, environmental law, copyright law, safety regulation all becomes advisory. Without multilateral orbital governance, space becomes the incubator for unconstrained optimization. The trillion-dollar cost of entry creates absolute digital feudalism. The platforms you cannot afford to build on yourself, they own the infrastructure that you cannot afford to leave once you're on them. The Collingridge dilemma explains why all 4 domains are in trouble simultaneously. When a technology is so new, regulation is possible, but harms are unknown. When harms are understood, the technology is too entrenched to change. The trap sits in the middle, harms becoming visible while the technology is still governable. We are in the trap right now across all 4 domains. The window to design the choice architecture to build friction and ethical gates into early deployment pipelines is open. It will not stay open. So the synthesis, I skipped the philosophical slide. It probably goes a bit too much into detail. I can, again, more detail on the philosophical side of my thinking can be found in my literature. So the matrix on the screen tells the story. There's 4 domains. In every one, a Skynet default and a heaven alternative. In every one, the Skynet default is what you get without deliberate choice. The heaven alternative is what you're designed to. The heaven alternative is hard work. It has to be chosen. So the conference theme is nurturing trust. So how do we know if we are winning? I apply what I call the feasibility test, 5 measurable conditions for the heaven vector. Every one is currently marked with a red cross. The majority of Fortune 500 organizations have not completed audited AI ethics reviews. They have paper policies that exist. Verified audits do not. There are no binding international AI treaties with arms control level verification mechanism. Deployment decisions in most organizations do not carry ethical veto authority. Corporate ethics boards do not routinely override commercial objectives. The statistical gap between stated AI commitments and actual system behavior has not narrowed. 5 conditions, none met. This is not pessimism, it's realism. A falsifiable test that returns negative results is the most useful instrument you have. It tells you exactly where to apply effort. There is no neutral ground. I want to return to where I started. AI is no longer a tool we use. It is an architecture we inhabit. That architecture was designed by someone. At each decision point, a choice was made. Usually quickly, usually under pressure, usually without the 4 specification questions. And the sum of those choices is a vector. There is no neutral ground. Every deployment executed without ethical examination is a preference for the Skynet vector, not a mistake, not an oversight, a preference expressed in code at scale. You are in this room because you understand that. Your organizations are building the systems right now. The question is not whether, it is which vector. Ask the 4 questions. Build the constraint. Name the vector. Choose heaven. These 4 books on the screen and the 2 reports that I've published are years of work and a lifetime, partly, of experience in the field. And they provide some of the questions and the answers of how we should progress. Enterprise AI governance and the sovereign data fortress, the hidden history of how the digital commons is repeatedly enclosed, military AI and the crisis of human control, the battle between an accountable heaven and an unfettered Skynet in orbital AI, and a practical guide to ethics in the age of AI. They're not philosophy, if though I use philosophical examples. They're not fear-mongering. They're practical frameworks you can deploy on Monday morning. Thank you.